but I wanted to first make sure that we know how to simplify these rational expressions when they are fractions, or two fractions that you have to put together. So that first one, I feel like it's so tiny here. Let's see. There we go. All right, so for that first one, when you have two fractions, you want to make it one rational expression. So I'll put this first one together for you, and then I'll have you simplify number two and make sure we have the two equations correct before we try to graph them. So to make this two separate fractions, anything you can write as over 1, and then your common denominator, you have to look at what the factors are in each of the denominators, right? So this has a factor of x plus 2. This has a factor of 1. So this fraction over here on the right has to be multiplied by x plus 2 over x plus 2, because multiplying by that is really like multiplying by 1. So I haven't changed the value, but I'm making a common denominator. And when you add two fractions together, like if you had 1/3 and 5/3, you still have thirds at the end. So if we have an x plus 2 denominator, x plus 2 denominator, our end result is going to be an x plus 2 denominator, because 1 times x plus 2 is x plus 2. So I need to add my numerators together. So I have 1x, and I've got 4 x's, and then I have 4 times 2 is 8. So altogether in the numerator, I have 5x plus 8. So that is actually the function that you want to answer all those questions about, right? The y-intercept, x-intercept, vertical asymptote, and horizontal or slant asymptote. There's no whole because there's no common factors that we're going to cancel. So in a minute, I'm going to have you do number 1 graphically. But before you do number 1, I just want to make sure everyone simplifies number 2 correctly. So I'm just going to give you a minute to simplify that one and check your answers before you graph it. So that's 9 over x plus 2x over 1. So you're going to make a common denominator, x, right? So multiplying by x over x, you get 9 plus 2x squared in the numerator, and then you get just x in the denominator. So then you're ready to graph number 1 and 2. So I'm going to give you a few minutes to graph 1 and 2, and then we'll check the video. So I did, you plug in 0. So when you plug in 0 here, you get 8/2, which is 4. So y-intercept is at 4. Your x-intercept, you look at where the numerator is 0. So that would be negative 8 over 5. And that's just a little bit more than negative 1. So it's between negative 1 and negative 2 on the x-axis. Your vertical asymptote is where the denominator is undefined. So that would be at negative 2. So there's my vertical asymptote at negative 2. And then the powers are both linear. So you strip the coefficients, and 5 divided by 1 is 5. So y equals 5 is here. So this elbow kind of naturally fits there. And then this one, I just plugged in a point. So I plugged in negative 3 into this expression, and I got positive 7. So I just plotted 3, 7 as the elbow in that top left corner. The y-intercept, the x-intercept, the vertical asymptote. But I want to show you how to do the slant asymptote with division. See how the numerator has a bigger power, and it has to be a bigger power just by 1. So x squared divided by x will give you a linear function. If this had been x cubed divided by x, your quotient would be a quadratic, and it doesn't make sense for an asymptote to be a quadratic. So your asymptote has to be a line. So if this had been x cubed over x, you could just skip it. There'd be no slant asymptote. So the only reason I'm doing division is because the numerator is higher by 1 degree. So like a cubic divided by a quadratic, you would want to do. But a cubic divided by linear, you wouldn't want to waste your time doing the division. So what you do is you set up a box. Usually our divisor is like 2 terms. In this case, it's x plus 0. There's no constant term. So just naturally, I usually set up my box with like, x plus 3. In this case, it's going to be x plus 0, just so I have kind of 2 terms for my divisor. if there were 3 terms, like a quadratic that's a trinomial, you could put 3 terms down the side if you had to. So then you always want to think of your dividend in standard form. So 2x squared is the leading term. That goes first inside your box. So your quotient is going to be up here, times your divisor is going to give you the dividend that you have in the numerator. So you have to think about what times x is going to give you 2x squared. So that's going to be 2x. So you just found the first part of your slant asymptote, 2x. 2x times x is 2x squared. 2x times 0 is 0. Did we need to get an x term? There's no x term up here, right? It's just a constant of 9. So if there's 0x term, it's really 2x plus 0 with a remainder of 9. So y equals 2x is the equation of the slant asymptote, which goes through the origin, like y equals mx plus b. B is 0, and the slope is up 2 over 1 as a dotted line. So this asymptote looks like a slant through your graph like that. So see if you can put that together with the other 3 pieces to see what this would look like. Let me just finish this for the sake of the video too. So let's see, our y-intercept. What's the problem? If we plug in 0, we get 9 divided by 0, right? So there's no y-intercept. X-intercept. I could never make the numerator 0, right? Because 2x squared plus 9 has to equal 0, and this is a quadratic, so that's never going to be a negative number to get me negative 9. So there's also no x-intercept. And my vertical asymptote, the denominator cannot be 0. So I'd have a vertical asymptote at x equals 0. So I need to, I'm guessing that my graph is probably in these narrow V shapes, right? Because there was no x-intercepts. But you could plug in like maybe 1 for x and -1 and see what you get. So if I plug in 1, I would get 9 plus 2 is 11 divided by 1. So 1 comma 11 is up here. So it must be really up high in that V shape. And let's see, if I plug in -1, I'm still going to get positive 11 for the numerator because -1 squared is 1. But then I'm dividing by -1 in the denominator. So then I would get -11, so kind of down here. So it must be just kind of a really narrow V-shaped graph. Let's just double check on the calculator so I don't lead you astray. But it was 9 divided by x plus 2x. Oh, I got to zoom out on my window. Oh, you can kind of see it. So you can see those little loops kind of up in the top and bottom. So does that look about right? Oh, I'll just kind of put these up here kind of quick. You can kind of skim through, and I'll kind of put the video up so people who aren't here can see it too. Yeah. We at least started with that correct equation. So my y-intercept was at -4 2/3. That's what -14 is. My x-intercept was about just about -3. 14 divided by -5. Vertical at -3. Horizontal at -5. When you strip the coefficients, there's no hole. I didn't cancel anything out. I'm just going to continue down with number 3 and come back to 4. So here's kind of what it looked like. And then the only exclusions were my asymptotes. X cannot equal -3. Y could not equal -5. Did we do okay on that? So I will try to give you reasonable questions where it's not too complicated with fractions, but because you're going to be graphing without a calculator on your quiz tomorrow, but you could use the note card just on your quiz. All right, so you could have these steps written down. How do I do the y-intercept? I'm going to put the questions in this order so that you're used to doing it in this order. I did cancel the x plus 3's when I factored. So there's 0 comma positive 5/3 because I had 2 negatives. 5 comma 0 for my x-intercept. y equals 1, because again, the powers were equal, so you strip the coefficients. Oh, actually, I think I switched the order of this, didn't I? Usually I ask you vertical first, then horizontal. I don't know why I did that over here, but vertical was at +3. My whole is at -3 from this guy. I plug -3 in, and I got +8.6. So here's kind of what it looked like with the domain and range. So this should be 21. It's just an old answer key. Is this the same? Like horizontal was at y equals 1. Number 2, the vertical asymptote, x equals -2. Number 3, this had no vertical asymptote because the denominator can never be 0 because you've got x squared there plus 4. The domain for number 4, you're looking at the denominator. Where would the denominator be excluding values for x? So at 2 and at +1. So I factored the denominator in number 4. Number 5, the powers are the same, x squared, so you strip the coefficients, y equals 3. And number 6, domain. So again, where is the denominator going to be 0? So this is solving a quadratic. So you would have x squared minus 10 equals 0. You'd add 10 to the other side and take the square root. So that's why x cannot be plus or minus the square root of 10. Does that kind of make sense? Kind of using a little bit of quadratic knowledge there. Any questions on 1 through 6 before I shift it down? Did you do okay? It's hard when it's like you got to nitpick this one thing. I need just the y-intercept, or I need just the, asymptote. Okay, so then let's see. Number 7, finding the real zeros. That's the x-intercepts. When you factor the numerator, it would be 3 or -3. Find all intercepts. So the x-intercepts were at 4 and -4 with the numerator, and the y-intercept +16/9 because you plug in 0 for x. So you have 3 intercepts on that one. So on your quiz, make sure you're reading what I'm asking. Is it the intercepts, the y-intercept, the x-intercept? Let's see, this had a horizontal asymptote. The denominator was bigger, so y equals 0 is the horizontal. The vertical asymptote would be at +1 because this is x cubed minus 1. So 1 is the only vertical asymptote that would make that 0. And then you said you wanted to see number maybe 10 and 12 done out. So I have a little video here for, okay, so this is 19, the very back page, writing equations that have these characteristics, because this is a little bit more challenging. So this wouldn't be on your quiz Wednesday, but there could be a question like a multiple choice, which of these, has this as a domain, or which of these has this as an asymptote. So this is a domain restriction, right? This is interval notation. It's saying that x can either be here or here. Basically what they're saying is x cannot be 7, right? Because x goes from -infinity up to 7 and then 7 to infinity. So this is just saying x cannot be 7. Where on the function is it going to make a domain difference? Where am I going to put that information? In the denominator. So there's lots of answers, but one answer would be like 1 over what factor would have to be in the denominator? X minus 7. I mean, anything with x minus 7 in the denominator would have that as the domain restriction, right? So now this one, number 6, this time the range has a restriction, and this time y cannot be 2. I can go from -infinity to 2 and then 2 to +infinity. How am I going to make a range restriction? There's 2 ways. You could either have a whole or you could have a horizontal asymptote. It doesn't matter which one you pick to do. So to me, it's easier to do the horizontal asymptote. If there's a horizontal asymptote, you want the power of the numerator to equal the power of the denominator. So for example, if they were both linear functions, like x plus 3 over x plus 4, let's say, those are both linear functions. To get y equals 2 as my asymptote, I have to have the coefficients be a ratio of 2. So for example, you could have like 8x plus 3 over 4x plus 4, right? Because then 8 divided by 4 is 2. I mean, you could just have 2x here, 2x over 1x. So there's a lot of different answers, but you're building a function that has one of those characteristics. So now let's see, this has to have a slant asymptote, it has to have a vertical asymptote here, and it has to have a hole this time. So thinking to the end of this problem, a slant asymptote, where does the power have to be the biggest for there to be a slant asymptote? Numerator. So just thinking ahead to that, let's build this. So it has to have a vertical asymptote at x equals 4. So I'm going to put a factor in the denominator of what? X minus 4. Right? That'll have a vertical asymptote at 4 now. So now if there's a hole, I want to be able to cancel these factors out. So I'm going to put a factor of x plus 1 over x plus 1 so that those would cancel and get me a hole at negative 1. Now I just have to make the numerator have a higher power. So you just need to add some powers of x. So if this is quadratic, we need to make the numerator cubic. So we could either cube this function or we could put like another factor of x squared in the numerator. Just something to make this cubic and this quadratic. But there's multiple answers. So you could have done like x plus 1 cubed over x minus 4x plus 1. That would also work. All right, why don't you try to do number 8 on your own this time, and we'll just see if we get examples that will work. So I'm just going to give you like a minute or two to try example 8, and then we're going to go on to page 2 of number 21 for practice. So the vertical asymptote and the hole, right? So let's see, vertical asymptote, so that's just x plus 1 in the denominator. A hole, so I need x plus 3 over x plus 3 to cancel out. You could, but that wouldn't give you a hole at negative 3, right? Because you want negative 3 to be what you plug in that makes it 0. Horizontal asymptote. So I have to have equal powers. So I could either make this a squared, I could put an extra factor of x, but I have to have x squared over x squared, and then I have to have a coefficient of 5 over 1. So you could have 10 over 2. You could have squared this term, something squared in the numerator, something squared in the denominator with a ratio of 5. Does that make sense? So you've got about 10 minutes left, and what I thought would be 16. If you have time, you could try these 2 graphs on the back, and if not, we'll do 17 and 18 maybe as a warm-up tomorrow before your quiz, if you don't have time, because I don't want you to have 21 as homework too. Just the book work is homework. But I think in the next 10 minutes, you should be able to do at least the multiple choice and maybe get to the bottom. So this is paper 21. We're doing 13 through 18.